Hello webs, hi, this is Fahad from Future Phones, and today I was fixing a Huawei motherboard. The model number is NBL-WAQ9R, and Huawei has decided to build laptops as well, but the worst thing about this laptop is the charging port. Charging port is such a bad design because it's directly connected to the board, and most people are having issues when they plug in the charger into this USB-C type, and they break the pins behind the charging port. So this motherboard has only one C-type connector, and everything that you want to connect, whether it's be a HDMI port, a converter, or your C-type data cable, or C-type pen drive, anything that needs to be connected is connected through this only single C-type connector, and it breaks so easily, and you can see probably I don't think you will catch in this camera. So we'll go into the microscope and we'll see what issue we are getting at the moment. I've already fixed the charging port on this one, but I'm still receiving 5 volts at the charging port. So this is one of the indicators. Then I have to look further into the board where there is a problem. So let's go into the microscope first, and let's check what do we get. So you can see, work it out, yeah. So you can see we are only receiving 5 volt and 030 amps, sometime milliamps, sorry, 030 milliamps, and it's changing, and now it's stuck at 5 volts. So this is one of the indicators that our charging port has been installed properly, but there is some other issues on the board. Let's have a look at the charging port first, what I have done so far on this one. So you can see there is some micro soldering that I've done. So this charging port was given to another technician before me, and they decided to work on it, and they could not fix the charging port. So I've used the same old charging port because physically from the front the charging port is okay. This C-type connector is good. Only in the back these pins were broken because of the design fault, and you can see I have put all the pins in here, and our charger is taking 5 volts consumption on this charging port. Now if it was a broken or a shorted one, then it would not take any voltages on the ammeter, but since it's taking some voltages, that means the voltage is indeed going inside the board, and the next step is where this charge of 5 volt is checked, and if the board is okay, then 20 volts will kick in and 20 volt will go into this board. But at the moment we are only getting 5 volts on this one. So I was just going through this board, and I did not find any of the slim port ICs that I'm quite often I see now, but some companies are using their own ICs, like Intel has its own IC for the data, but in this board I don't see anything like this. So I was just checking here, so we did not find any shortage on any of these pins now after I put this connector on. So all this area is clear. Next thing is I want to show you what I usually do when I receive a board. When I receive a board and let's say I'm changing the charging port, or I've fixed a board, I like to make some information or data of the working board. So how that looks I will show you in this desktop here. So that's how it looks. I'll just make this picture big, and you can see this is from a previous repair that I was working on, and I have marked the coils with what sort of voltages are available. For example, this coil will receive 5 volts and this will receive 3.3 volts, and if they are always voltages, for example, as soon as you connect the charger the board is off, so these AL voltages are always present. So 5.1 is always present here, 3.3 is always present here, And as similarly here you can see 0.82 volt, and then we have here some values in the diode mode range, and here 0.90 volt, and at the battery coil here we are receiving 0.0644 AL. So this is always voltage is minimal voltage is less than 1 volt. So when the board is in the sleep mode, at that point there is no charge at this point here, but as soon as you plug in the charger, so AL voltages should be present. So this is how I make it. And then another thing that you can see here, this is the diode range value of this coil here, which is 0.4460, and this is a healthy value. And if anything is dropped, for example this becomes 200 or 100 or short to ground completely, then at that point I will look into this area. And similarly here you can see here we have 0.1474 and 0.4214. So this is my next step when what I want to check on this board. And I've already tested that, and one of the coil is has a different diode mode range, and I will show you which one it is. Let's go into the microscope. So we are looking at this coil, which is the 3.3 volt always line, and the diode mode range value is 0.4214, but we are receiving a different one here. So let's go into the board and check. So we are here now, so you could see these are the two coils we were looking at. So one of them is the 5 volt line and the other one is 3.3 volt line. So I'm in the diode range now, and my red probe is on the ground, and black I'm going to touch with the black this coil first, and you can see we are receiving 0.4549. so this is a healthy value. But when we come here, you can see it's completely short to ground. This is not supposed to be ground. So this could be the reason this laptop is only receiving 5 volts and not 20 volts. So there is a shortage in this area. How to confirm there is a shortage in this area? We will again do the same thing. We definitely know that this coil has two sides, and we need to figure out which side of the coil has shortage on. So we will remove this coil first, and I will remove this coil now. Use some flux, and I'd like to use my soldering iron as well. You can see I'm removing this with the soldering iron. Okay, so this is removed. So after I removed it, we need to confirm from which side has the shortage. So we will go into the diode mode range again, and the red probe is on the ground and the black probe is here. So I'm going to touch here first, and you can say we have a healthy value on this side. So if we connect here, then you can see it's completely short to ground. Now at this point I will inject some voltage and check which component in this area has short. So if I go into this big board view now, so we can check. So I will, my DC power supply is at only 1 volt and 2.5 amps, and I will try and see if this thing works now. So my thermal camera is ready, and I'm going to inject the volt now, and it's only 1 volt, and you can see this IC is heating up red hot. So we'll just is the IC right above the wire. So I'll just check. We will just check now. So which IC is this? This IC is 51393P. What I'm going to do now, I'll remove this first, this wire. I'll check around this IC what sort of condition it is in right now. So we are in the diode mode range again, and we will check this IC. So you see it's a healthy value here, healthy value here. So these pads are ground, so that will be ground, all these will be ground, that's fine. And now we'll check this side of the IC, which is okay here. Okay, one pad is ground, that could be fine, but another pad is ground, another pad is ground. So many pads are ground. And if you look into the schematics, I've got the schematic for this IC, and so this is the TPS 51393P, and you can see this IC has, okay, pin number 7, 8 and 18 is ground, that's fine. And then we have the win voltage coming here, enable voltage is coming here, VCC is coming here, enable LDO is coming here. So this IC is also generating a 3 volt LDO possibly. So there is the LDO line, these two are NC not connected, and this is the thermal pad to check the temperature of the board, and this is the feedback line of the voltage out here, and this is the switching power supply, and this switching power supply goes past this coil. This coil we have just removed this coil, and after that you can see this is the feedback line, and we have a boost resistor here, and the capacitor, we have a boost capacitor here. So this is the structure of this IC. So we have only one pin number 7, 8 and 18, they should be connected to ground, but this IC is heating up, and we are going to find if anything else apart from 7, 8 and 18 is short to ground, then we will definitely remove this IC. And let's go back to the microscope. 7, 8 and 18. So these pins, if this is pin number 1, 2, 3, 4, 5, 6, 7, 7, 8, and you can see okay, that's fine. Pin number 10 is also short to ground, this should not be short to ground. 11, 12, 13, 14, 15, 16, 17, 18, so this is ground, that's fine. 18 number, but you see this pin is also ground, this should not be ground, this pin. So after that we can, I looked for this IC and I found out that I have a board which is the replacement board I have, which is FB0024, and I've got the IC in this board, and I have taken this IC from this board. Okay, so where is this IC now? Okay, you can see here in the microscope now. So 51393P, this is our replacement IC. So if I take this IC off this board first, okay, so this IC is removed. Okay, and my IC is going to replace this one. Use some flux. We need to remove this IC now. Okay, let's tin the pads of corners of this IC. So this is a kind of low melt solder cellulated wire. Just make it easier to put the IC on now. So let's change this IC now. Let's see. And what we need is the orientation of this IC. This IC is connected. That's a new IC. Let's check if we still have short on these pads. So we don't have short anymore. You can see it's a very healthy value on this pad now. So we will put the coil back on. Before we put the coil, I want to put some low melt solder on this pad as well. That's okay. Let's put the coil back on. Okay. Clean it. Okay, now let's check it, what it does. So our test is again the same. We will use the amp meter and check if we get 20 volts now. Yep, we have a 19 volt. So this board should power on. The rest of the check we will do after we have put this machine into the board. And you can see again, so the resistance on this coil is healthy again. So this IC was faulty and it was stopping this board to power on. You can see it's a healthy resistance. It normally is about 400-500, but this board is warm at the moment, so that's why you are seeing this value. Normally it should be about 400. So yeah, that's the healthy value. You can see. Okay, so we have put this laptop together now, and it's in the almost close condition. We have also checked it, and you can see when I connect the amp meter is taking voltages, and if I come in this, you can see here it's taking about 19 voltages. And if I press the power button, because for this laptop you need to connect the battery and then press the power button, and then it powers on. You can see it's powering on now. So this laptop is fixed now, and our job is done. And thank you very much for watching. I hope you've learned something from this video, and do like and subscribe to the channel. And if you have any questions, you can leave them in the comment section, and I will try my best to answer. Thank you very much.